Good morning, everyone, or good afternoon, as the case may be, depending on where in this world you're sitting right now. My name's Hugh Peterson. I am the product manager for standard imaging for our PIPSpro software, our machine QA software that covers just about all your TG-142 machine QA needs and more. Today, I'm going to kind of give you a somewhat of a brief overview. It won't be an in-depth view of the software at all. It'll just kind of be an overview. And I invite you to feel free to get in touch with us to take a look at the software more in depth. I'd be happy to give you a kind of a deeper dive into the software. But today, it's just geared to be an overview of what we offer for the software. So basically, our PIPSpro software, it's easy machine QA, automated machine QA for TG-142. We also offer it in combination with our our QA pilot software, which we kind of call the combination QA Fusion. And that Fusion is actually the test component within PIPSpro, as well as the QA management component of our QA pilot software, and I'll touch on that a little further down the presentation. But to start out, just a little bit of housekeeping. You are all on mute just to avoid any kind of confusion and issues with contact. But there is a question box on your interface there. So any questions you have, please enter those right into the question portion of the interface, and I will address those at the end. And this is being recorded, and basically everybody who has registered for the presentation will receive an email with the link for the presentation recording afterward. And if you want to kind of revisit it yourself, or you want to share with colleagues that aren't available to attend right now, feel free to do so. But just a bit about standard imaging. We're based in Middleton, Wisconsin, which is just next door to Madison, which is the state capital, obviously. We do have a very good relationship with not only the University of Wisconsin Calibration Lab, but also the Cancer Center at the university as well. So they do some testing for us, and we do some. They help us with some development of the products, et cetera. So we've been around since 1989, so we're just about 32 years now. So we've been been around quite a while. We've got a lot of history behind us, and as such, we design and manufacture a full suite of QA products. You probably know us for our well chambers, electrometers, ion chambers. We also have a full suite of software, including the PIPSpro software, our I am sure secondary check software, our Adaptivo software for patient dosimetry, utilizing the EPID, as well as an adaptive module contained in it, and also our LinAcView software, which is a log file monitoring software, as well as others, and then a whole host of phantoms, including the Lucy Phantom, which is kind of the gold standard for stereotactic QA. But anyway, let's move forward, and we can learn a little bit more about PIPSpro. So basically, PIPSpro is it's filmless for just about all tests. You can also use film in some of the required tests as well if you desire. It's all quantifiable TG-142 QA. It's automated analysis of over 30 TG-142 recommended QA tasks, including, and my PowerPoint's not moving. One second here. There we go. Planar imaging for both MV and KV, as well as our cone beam CT. For the MV and KV imaging planar QA, we've got our own set of phantoms for that, our QC KV and our QC3 phantom. The cone beam CT QA is done actually using the Phantom Laboratories CAT fan, and we've got the specific capabilities to do either tests for the Electa 503 Phantom or the Variant 504 Phantom, as well as the 600 series of CAT fan. We've got a couple of different types of various MLC QA tests, including our image-based test, which covers our picket fence test, our leaf position test, leaf transmission test. Then we also have the log file based MLC tests as well, which include leaf speed, which is an actual leaf speed, not an average. And then also reproducibility or repeatability, if you will, for leaf movement as well. Have a stereotactic component, which is an automated Winston Lutz. You bring in your different couch angles slash collimator angles and gantry angles, and we will calculate the best, most beneficial shifts for you in 3D. Have a radiation light field component as well, which also includes a central axis check also. A star shot analysis for doing gantry, couch, and collimator star shots, so that functionality is there also. And also we have a IGRT database package as well that's included. So all these are part of the PIPSpro standard package, and does like I said, about over 30 different TG-142 recommended QA tests. And if you get in touch with us afterwards, we can get you a listing of those tests that are performed and by the recommended TG-142. But kind of moving on, you know, the nice thing about the software is it's scalable. So if you're just a small center with a single LINAC, or you're a full component group, if you will, say some of your larger groups, or you have a number of different centers under one umbrella, you know, it's scalable to that enterprise, or like I said, just a single facility with a single LINAC. It's built to be kind of to grow with you, if you will. Very easy department and user setup for the software as well. It can be settled onto set up on a Citrix server, so you can access it from anywhere in the enterprise and any PC in the system. It's a centralized data access for that enterprise-wide results and trending. So you can kind of take a look at if you are part of a larger group, you can kind of see what the other facilities, how their results are, and kind of compare yours to theirs, etc. So that functionality is there as well. And then it also nice, you can set up easy baselines, and those give you quick select, so you can just jump right into your test. You don't have to do any setup. It's just you grab what test you want to do and bring in the results, and it will calculate everything for you as far as the imaging or MLC tests, things like that. Everything is kind of at your fingertips. And more setup specifics here. You can you keep your individual LINAC data separate for ease of use and reporting for, again, those comparisons from LINAC to LINAC. And there's a threshold with threshold settings within the system manager as well. That are set up initially. They kind of come standard with the TG-142 tolerances already completed and filled in there for you, but those are adjustable. You can loosen those or tighten those tolerances as you see fit for not only your alerts but also your error thresholds. There's also a nice feature. We have what we call our QA results dashboard, and that's kind of an overview of your last test results and the date and whether they pass or fail results on there as well. So it's just gives you a very visual, quick and easy review of what needs to be done, what has to be done yet, what has been completed, etc. For our planar imaging, like I mentioned, we have the KV and the MV, so not only for your OBI or your onboard KV imager, but also for the EPID. A couple different phantoms. We've got the EPID-based phantom and the KV-based phantom. Similar in scope. The tests are very similar, so you don't have to kind of learn multiple tests. They give you the ability to check your resolution, your noise, your uniformity, your contrast to noise, all in an automated calculation and a single test. You just take an image of the phantom and a flood field, and it gives you the results automatically. So you have that spatial resolution, that uniformity, that contrast, and that contrast to noise. The cone beam CT, again, like I mentioned, utilizes the CatFan series of phantoms, our 503 for the elective systems, the 504 for the variant systems, as well as the 600 and the 604 phantoms if you want to do some diagnostic checks as well. These tests again include uniformity of noise, the house field unit constancy, any geometric distortion, your slice thickness, your low contrast visibility, your low contrast detectability. And you can kind of see on the right here showing you, this is just an overview of the results, but you can click on any one and then you can drill down into the actual slice that you'll see for those specific tests. For example, here your geometric distortion or your slice thickness, looking at those step wedges within the phantom module itself. So you can kind of take a look at each individual test with more detail, but you also do get a color-coded pass, caution, fail for your different tests in a quick overview. Like I said, we also have our log file based leaf speed test. And the nice thing about our tests, we actually look at each individual leaf. There's some other systems out there that just kind of give you an overview average of kind of the dose rate of the windows, where we actually look at each individual leaf and give you results for each of those individual leaves. For example, here on this screen here, showing you the leaf speed results here. You see a lot of the internal leaves that are used more frequently will typically give you much better results. The outer leaves that may not be used quite as much or quite as often for the treatments may see some sticking or some lubrication buildup, things like that might cause some slowdown. So you can kind of monitor again each individual leaf for that leaf speed. We can do travel speed itself, so we actually check and look for that leaf speed loss. You can do segmented step and shoot IMRT. You can do moving window IMRT as well from your 4 cardinal gantry angles. And then we also do a repeatability test also. And you can use not only the set patterns, but you can also take a look at actual treatment patterns as well. So you can bring in a log file or trajectory file from Varian to take a look at the actual treatment window that is being used for an actual plan. Our image-based MLC test, like I mentioned, we have the multiport or picket fence test, which you can see here on the left, and then the results on the right. Not only visual, but also in a table format. I have a leaf position accuracy, which gives you the position of each leaf comparatively for your left bank and your right bank, as well as a leaf transmission test. The radiation light field coincidence test, we have a phantom, which is known as our FC2 phantom, and that gives you the ability to check a 15 by 15 or a 10 by 10 field against the light field and radiation field. And basically, there's 4 fiducials in the corners that the software will find, and then they also will detect the radiation edge and compare that to the set light field. And knowing that the positions of those 4 fiducials, it will run through the calculation of the algorithm and then give you a report like you'll see here on the right, which shows you not only your radiation crosshair displacement, but your light field crosshair displacement and your radiation light field displacement as well. So you get all 3 of those in a single graph component. And then the star shot analysis, we can utilize either EPID or film. We can do gantry, collimator, and couch. It's a quick one-click analysis. When you bring your image in, it's a composite image that you set up within utilizing the EPID, and then you just have to click on the really anywhere in the center. It doesn't have to be perfect. The software will find that center. You just kind of give it a quick guide. Once that center is clicked, you will automatically calculate the results, and will pop into the results page you see on the right, and that basically gives you per TG-142 the smallest diameter circle that incorporates all the rays of the star shot. So it kind of gives you a not only a pixel size, but your image dimensions and your minimum diameter here for the test. So it's pretty straightforward, easy test to perform those star shots with. Our automated Winston Lutz test basically can be either utilizing the MLC-based stereotactic modules, or a cone-based system if you prefer. Obviously, the square fields on the right are MLCs, but it will calculate those optimal 3D shifts. Basically, you bring in up to 8 images. The more images, the more detailed and precise the calculation will be for the 3D. But the green square is basically the software will detect that radiation field edge, and then the green crosshair, that's your radiation center. The yellow crosshair is its detected center of the ball marker. So it will give you those results in a cross-plane and in-plane position, but then utilizing those, it will then calculate your 3D calculated for optimal shifts here. And basically, you can utilize just about any Winston Lutz phantom, whether it's a pointer or a cube phantom. It's available to detect and utilize either types of those, and we have both of those available. We've got not only the pointer, as you see there on the lower left, but we do also have a cube phantom. We also have a 3D adjustable phantom, which has X, Y, and Z micrometer adjustment for precise movement of the ball marker, and that's available as well. And then we also have an IGRT module, and this is basically utilizing a phantom, a cube phantom similar to our Mimi or some other IGRT phantom out on the market, just giving you the XYZ deviations for positioning, so you can enter those in, and then you can kind of track and trend those over time. So it's more of a database kind of system, as opposed to a true quantifiable tests per se, but it allows you to kind of track and see how those 3D or 2D definitions for your positioning are. And then also you can also track, if you have a 6D couch, you can track those pitch, roll, and yaw results as well. And then you can track them in a trend line. So I'm just going to jump into the software just a little bit. I'm not going to, like I said, go through. I'm just going to kind of show you a couple different tests, kind of show you how easy they are and to get those results. So let me quick jump into the software here. So here's our front page. Basically, I can hide this dashboard, but this is just kind of our title page. As you enter the software, the dashboard will pop up, and like I said, this will show you not only your last analyzation date of your test, also what tests are being performed, what application they are, and then your results here in either a green, yellow, or red fashion for pass, caution, alert, or a failure. Nice thing too, they're not only are they color coded, but they're also shape coded as well. So you have, if there are any issues with the ability to see colors, as far as color blindness or things like that, that's covered as well. So you can see the square as a pass, a triangle as a caution, and a red as a circle as a fail. We also, as I mentioned, have the ability to incorporate it into our QA pilot software, and I'll touch on that a little more when I get back into the presentation itself. But we just have the QA portal, QA pilot portal here, and click on that, and you can pick and choose what test results you want to send into QA Pilot. Either you can select them all, or I can just do some individual ones if I want to send those over. So that's automated push up into our QA Pilot software. Going into our system manager, this is kind of where you quickly set everything up. Like I mentioned, if you have an enterprise type setup, you can set those up as a division, and then your individual departments can sit under that. You can enter those in Maple Hospital or whatever your facility name is, etc. What users will be using the system, and the nice thing is we have different security levels. So we've got an administrative level, which allows you basically to utilize everything. You can change the threshold, you can add users, add departments, things like that. There's also just a basic level which allows you to kind of perform the tests and bring the test data in, but you can't do any manipulation, things like that. So there's different levels of security to keep things kind of straightforward within the software. Your LINAC setup as well. You can set up your different LINACs, serial numbers, MLC type, whether you have a 3D or 6D couch, things like that. So it's a quick and easy setup there as well. Your threshold page, setting up those thresholds. Like I said, it comes preset with the TG-142 tolerances, but you can adjust those, tighten those, or loosen those as you see fit. And then information on the Phantoms themselves. Nice thing about our QC KV and our QC3 Phantom, they come actually calibrated from the factory with preset region of interest areas with set frequencies measured at the factory. So those are come pre-calibrated, so you'll always have the most accurate results based on those calibration numbers. So that's the system manager. Just give you a couple examples of some of our tests we do. We have the imager QA, as I had mentioned. I'll kind of touch on that. We've got the quick select. So once a baseline is set within the software, you can go and you can choose those quick selects. So here I've got a QC3, which is my MV test. I've got my QC-KV, which is my KV test, CBCT test as well. I'm going to jump in and show you the QC3 test here, and then I'll show you the cone beam test too. Basically, I just go in, and it's got a memory, which is nice. So you'll when you click on load, it will grab, it will go right to the preset folder or directory that you set for a specific test. So in this case, I'm going to grab my Phantom image and my flood field. I'll bring those in. The software itself will automatically locate and localize on the regions of interest within the Phantom. And if they look good, if not, you can adjust those, but typically they come in and they find those without a problem. You can accept that. It'll bring in your flood field, and it'll do automatically calculate the results for you once you choose the Phantom acceptance, and then you get your results here. So you get your results for your F50, F40, F30 resolutions, your uniformity, your noise, and your contrast to noise. You can see the Phantom image here as well as the flood field. The flood field, the software will detect not only the darkest area and the lightest area, but five random spots around the Phantom for not only your contrast to noise and your noise, but also your uniformity. So those are all automated results there. So that's kind of the results there. You can do a full report. You can save those, and then you can look at a history view, which will give you your trend lines, things like that. So that functionality is all there, as well as your MTF curve for your resolutions. The cone beam component, very similar. You automatically will be directed to that cat fan localization there. I've got my variant 504 here for my true beam. I choose that set, my most recent set that I want to do my test on. I open that up. Automatically will, oh, that was strange. It worked yesterday. There we go. So it goes and looks for what's known as the key slice within the Phantom itself, and as it runs through its calculations and detecting components of the the Phantom itself. Like I said, for variant, it's the 504 Phantom. For elected, it's the 503 Phantom. Same Phantom, just different order and different pieces of slices within the Phantom. So it basically what it does, it looks for what we call the key slice, and it keys on that, looking for these pins, and then it knows kind of where the rest of the components are. So I can click on those results. Here's my results page here, my overview. I've got my uniformity of noise, my house field constancy, etc. I can click on any one of those tests that I want. It will bring up the pertinent slice itself. And for example, here, my Hounsfield consistency, I can look through it's got my 8 different densities around the Phantom. I've got a couple of air pockets, but I've got also polystyrene, acrylic, Delrin, etc. Your expected Hounsfield units and what the software measured for those densities. So things like that. So again, you have all that full capability there for your number of different tests. And again, you can have your check. You can pull down this menu too and go to your different tests, spatial resolution, checking your line pairs, things like that. So that functionality is there, very easy, very quick, and very automated. One other one I want to maybe show you just before we kind of finish up here. For example, I can show you our log file based MLC QA. So again, I can load in my specific trajectory files. Here we have a couple of preset examples, are complex or simple, or repeatability, but then you can also, like I said, bring in specific treatment plans as well. I have a prostate plan and a neck plan, as you can see here, but I'll bring in my complex and I'll open that up, and that will open the field. These are a little slow today. Oh, and I apologize about that. Not sure what happened there. Let me bring that back up real quick. I think I have too many things open on my laptop today. Let's try this again. So I will. There we go. So basically, you can kind of take a look. This is what we call our complex, where every other leaf will move a given position, and then the other opposite set will move as well. So it just kind of gives you a movement. We also have a simple one which moves all the leaves at once. But I can go ahead and I can calculate this, and what you get then here, like I mentioned, is every leaf is accounted for. It's not an average of the leaf of the window. It's actually each individual leaf accounted for. So I can hover over any individual leaf, and this one, leaf 40, it's showing me I have a leaf speed loss of only 1.37 millimeters per second. So that's well within the passing. You can see here the passing is set to 2.5. Anything slower than 2.5 as far as leaf speed loss goes, you get a caution. Anything greater than 5 millimeters per second, you get a failure. So those are set to the TG-142 tolerances. And you have your in this little matrix here, you've got your 10 worst culprits, if you will. Where the A bank and the B bank gives you your 10 worst offenders of your leaf speed. So it's a quick and easy test. It's a quantifiable test. Each individual leaf is accounted for, and then you have a good visualization of how those leaves are actually performing. So that's kind of a quick overview of a couple different tests, but like I said, if you want to take a more in-depth and a deeper dive into the software, please feel free to get in touch with us, and we'll be happy to do that. And let's see. So going back to my PowerPoint here, This is, as I was talking about, our QA Fusion connectivity. We can directly upload our results from our tests into our QA Pilot, QA management software. So that will give you those results there. You can see there it's a scheduler as well as a data base for your test results. You can do full reporting as well for your specific tests. So your PIPSpro, the advantages, it's a fully quantifiable and repeatable results of your machine QA. It makes it easier for your center to become compliant with that recommended TG-142 task group recommendations. It's a centralized database and very scalable to your specific needs, like I said, from the smallest single LINAC facility to the largest enterprise-wide systems. The results dashboard for a quick visualization and single view of those most recent results. Everything is quantifiable. Everything is tested with precision phantoms where required, or those actual test results for, like, say, the log file presented by the LINAC. Very intuitive user interface for each component, easy to use, very straightforward. It's a smart software. Any of the phantoms that have targets or fiducials or field edges are automatically found and localized, and gives you results with less mouse clicks. Everything, kind of an automated results for just about all the tests. And again, like I said, over 30 TG-142 tests in a single package. So it's a very wide-ranged software as well. But that's all I've got for you today. Like I said, if you want to take a deeper look into it and kind of go through each test that we offer test by test, I'd be happy to oblige that. Feel free to contact us. You can contact us through our website, standardimaging.com, or for contacting our sales group, sales@standardimaging.com, and then your regional representative will or your distributor will contact you, and we can schedule a demo or get you more information accordingly. But other than that, I'll take a quick look to see if there's any questions today. And I don't see any. But if you do have any questions after the fact, feel free again to contact sales@standardimaging.com, and the responsible representative or distributor will get in touch with us or myself, and I can answer any questions that come up afterwards. But other than that, I thank you very much for your time today, and please feel free to visit standardimaging.com for all your QA needs, again, from electrometers, ion chambers, to phantoms, to QA software. We've got quite a host of products available. And I thank you very much for your time. Have a good rest of your morning or afternoon. Thank you.